This program is about today and tomorrow, the demanding present and the challenging future. It's about engineers and engineering, without which nothing in this modern and exciting world would be possible. Engineers putting their knowledge of nature and her products to practical use for the betterment and advancement of all mankind, matching the demands, meeting the challenges, breaking the barriers. This program in the series Breaking the Barriers is brought to you as a public service by South African Transport Services. The main function of SA Transport Services is to move people and goods, large numbers of people and large amounts of goods, as economically and as safely as possible. One of the most energy efficient and cost-effective methods of transporting in bulk is using the steel wheel on a steel rail. The task of ensuring that those steel wheels are utilized to maximum efficiency rests to a large extent on the shoulders of the professional engineer, or a team made up of various engineering disciplines. It is these engineers who must overcome the many challenges presented in a modern economy. Take one example, the export of what is perhaps our most abundant mineral, coal. Coal is one of our most important exports. But our coal fields are situated a long way from the export harbors. Once all the different factors of the situation have been weighed up and discussed at a very high level at SACS, the strategic importance of coal, the need to earn foreign exchange, the likely customers and likely income, men like these, many of them engineers, all of them in top management positions, execute the plan. The decision has been made. Build a rail link that will carry primarily coal at a cost that will keep the price of our coal competitive on the world market. This is the sort of challenge that is given to SATS engineers, whose thorough university training has equipped them for this task. Mountains to be skirted, avoided or tunneled through, rivers to be avoided or bridged, ravines to be crossed, gradients to be maintained at optimum levels. The engineering disciplines that formed part of the SATS team were the civil engineers, whose responsibilities were, and still are, the bridges and viaducts, the embankments, the tracks themselves, and the tunnels. The special trucks are the responsibility of the mechanical engineers. Everything electrical was handled by the electrical engineers. The signals and telecommunication engineers provide the means for the smooth running of the traffic on the line, the signals, the movements, the counting and registering of trucks, and so on. Whenever a decision is made to construct a new line, an enormous amount of planning and preparation must be done by all the various engineers in the team. For example, before even the first bulldozer can set out for the site, the civil engineers and technicians have to conduct soil and rock tests, testing the natural foundations, investigating and planning with an eye to drainage and the runoff of rainwater. With all the facts known, the engineers draw up a computer program that simulates the project, which predicts possible problem areas and defines exact requirements. By the time the actual construction began, every centimetre of the route had been carefully surveyed and planned. All bridges, viaducts and tunnels had been designed down to the last detail. The laying of the tracks could proceed uninterrupted. Even the impact on the environment had to be gauged and arrangements made to rehabilitate the area where necessary. No ordinary civil engineering this. The line has to carry trains of up to 200 trucks, each with an axle load of 26 tons. Every bridge, every viaduct, every culvert had to cope with trains with masses of over 20,000 tons. In engineering a project like this, SATS will also make use of technical expertise from a variety of outside firms. Research and planning was also being carried out by the mechanical engineers. Never before had trains of this size and mass been used in South Africa, so there was a good deal of new ground to cover. The special trucks that were used, large, spacious and robust, would each carry 84 tons of coal. Special couplings and braking systems were designed, and special attention given to the wheelbase or bogies. Even the rails and sleepers were specially designed to carry 20,000 tons per train day in and day out. The mechanical engineering requirements at the export harbour of Richards Bay form part of the responsibilities of the mechanical engineers. While not part of the SATS operation, they are an important element in the mechanical activity on the coal line. Various other bulk commodities are handled at Richards Bay and other harbours. They are all the responsibility of the SATS mechanical engineers. The entire line is electrified, so the electrical engineer is a vital member of the team. The electrical supply comes from the national grid at 88,000 volts, but the locomotives operate at 25,000 volts. Substations and transformers are required and positioned at regular intervals along the line. With every major project, the design and specifications for all the electrical equipment are drawn up by the electrical engineers. They also supervise the construction activities and ensure that the required standards are met. Their responsibilities include the electric locomotives. They make the optimum use of electrical energy to transport the load at the cheapest cost. Modern technology, for example, computers on board each locomotive, controls the power at the interface between wheel and rail. This coach is a laboratory on wheels. It houses computerized measuring equipment used by the electrical engineers and the mechanical engineers to conduct extensive measurements of the behavior and performance of the locomotives and the power supply while the locomotives are operating at maximum capacity. This is essential to verify that the engineer's design calculations were correct and to allow him to make final adjustments to obtain peak performance from the equipment. In order to keep trains moving safely along the line at the maximum tempo, so as to ensure that the line is used cost-effectively and at its maximum capacity, a complex but highly effective system of traffic control is used. Designed, introduced and maintained by SATS signals and telecommunication engineers, the system is amongst the most modern in the Southern Hemisphere. The complete track layout is represented in diagrammatical format in the control center, with every signal and set of points reflected on the diagrams. The whole system is computerized and train movements are carefully worked out in advance to ensure, amongst other things, that once these huge trains start moving, they do not have to stop without good reason. Restarting a train 2 kilometers in length, especially on an incline, consumes enormous amounts of electricity. Another computer-controlled system keeps an up-to-the-moment record of how much electricity is being consumed by the various locomotives on the coal line. The operator can see at a glance if consumption exceeds the optimum level, and he acts accordingly to reduce the demand. A variety of electronic equipment helps to prevent problems that might lead to damage to the rails or even derailments. The electronic engineers have come up with equipment that monitors the temperature of each and every wheel bearing to prevent them seizing. The dragging equipment detector warns the control room if anything is hanging down onto the track, and they can contact the driver immediately. The wheels of every train are counted when it leaves a station and again when entering the next station, to ensure that a train remains complete en route. Each truck has a number that is automatically read and transmitted to a central operations office to ensure complete records of the movements of trucks. All this forms part of an overall communications network that must overcome the barriers of vast distances and natural interference, such as lightning, to maintain a safe and steady flow of traffic and information, not just on the coal line, but also of all train movements throughout the entire country. It makes use of a variety of electronic equipment in an incredible network, which is one of the most modern and efficient private systems in the world. It takes the combined skills, training, expertise and vision of all the different engineers to bring a huge project like the coal line to reality. Day in and day out, huge trains trundle their loads down to the sea on this incredible line. Trains so long that at times one section is traveling uphill while another part is moving down. Because the trains are 2.5 kilometers long, the driver is told by remote-controlled radio what his last truck is doing. These remarkable trains carry an annual load of 45 million tons of export coal down the line to the ships in the harbour. A line that is now fully operational. A line that cost millions to build, but which brings in millions in foreign exchange. Does this mean then that the engineer's task is over? Is his job complete? Far from it. There is still maintenance to be planned and carried out, unforeseen circumstances to deal with, all part of the ongoing work of the different engineers. But most of all, there are the barriers of the future to be broken. How can we improve? How can we make it better? Can it be made safer or more efficient? How will we go about it next time? No matter how large or how small the project, there is never a shortage of challenges for the professional engineer at SA Transport Services. Challenges on a scale almost unequaled in the country. Barriers to be broken for the future well-being of our transport system and the future development of our country as a whole.